thing we'll do is I'll take that square root of negative 3 and write it as square root of negative 1 times the square root of 3. The square root of negative 1 is just an I. So we'll take that, bring an I out in front. The second thing I will do is take e to that and take advantage of a property of exponents. If I have x to the a plus b, that's the same thing as x to the a times x to the b. So if I have e to the negative 1/6 t plus I squared to 3 over 6t, that's the same thing as e to the negative 1/6 t times e to the I squared to 3 over 6t. And I can do the same thing for the second term. Like that. Then I can factor out e to the negative 1/6 t from both terms. And I get ae to the I squared root of 3 over 6t plus b e to the negative I squared root of 3 over 6t, like that. Okay, now I'm going to use another relationship. Normally prove it. It's not too hard to prove. I might prove it another day, though. For time reasons, I want to get done a certain amount of stuff in 40 minutes, so I'm going to skip that proof for now. It involves writing a Taylor series for e to the ix, a Taylor series for cosine x, a Taylor series for sine x. Show that if I add those two Taylor series together, I get that. You can prove it. It's a good review of count 2 Taylor series. It's good to do. You still may do it. But for now, let's just take this as already accepted. So this, oh, go ahead, Isaac.
How come? Oh, because it's plus minus. Okay, never mind.
Okay.
Wait, why is it cosine of x plus I sine of x?
If we worked out the Taylor series for this and the Taylor series for that, and the Taylor series for that, I would need an extra I to make these two equal to that.
Oh, okay, yeah. You're right.
Okay.
So I'm putting an x on
I'm going to use this for here, but before I do that, let me use it for a couple other things first, so we can get a little comfortable in. I know you've seen this in differential equations, maybe some other math classes as well. Suppose I have a complex number. What I mean by a complex number is a number that might have a normal part plus an imaginary part. So suppose I have a complex number, 1 plus 5i. There's my number. Has some imaginary part and has a regular real part. I can take that 1 plus 5i, and I think without any of your objections, I can write that as the square root of 26 times 1 divided by the square root of 26 plus 5 divided by the square root of 26i. Does anybody have an objection? You might not know why I've done that, but do anybody object to me doing that? No. Okay. What do you think is special about the square root of 26? If we were just to take a guess, where do you think I got that from? Looking at the numbers given there.
5 squared plus 1 squared.
Yep. Okay. These two components, it's a lot like finding unit vectors in statics class. These two components, if I did this squared plus that squared square root, they add up to 1. What is cosine squared plus sine squared if I added those together? 1. Yep. So what I'm going to do, if I write it so that this squared plus that squared adds up to 1, which I've now done by factoring out the square root of 26, just like picking a unit vector in statics class, I can take that cosine x, and if I pick the right value of x, I can make cosine x equal to 1 over the square root of 26. And I can make sine x equal to 5 over the square root of 26. So if I pick the value x correctly to make this true, that will also be true automatically. Let's try it out. I want cosine of x equal to 1 over the square root of 26. Let's do that and solve for x. So cosine x equals 1 over the square root of 26. Can someone solve that for x? Tell me what you get. how about degrees?
I got 78.7.
Agreed.
Did you remember to do cosine to the -1?
Yeah, that's what I did.
No, not you,
Oh, okay.
Okay.
Yeah,
I did inverse cosine of 1 divided by radical
Yeah,
26.
We got 78 degrees, right?
78.7.
78.69.
I do that all the time.
I just did 7.
Okay, now somebody else. What is inverse sine of 5 over the square root of 26? It better be, right? Let's make sure.
Same thing.
Same thing, okay? So do I need to do it twice to find x? No, I do it from pick one or the other and I can get x. So I can write the number 1 plus 5i as the square root of 26 times cosine of 78.7 degrees plus I sine 78.7 degrees. So I first wrote it this way. Now I took this and I'm trying to make it look like this equation here so that I can write it as the square root of 26 times e to the something. What should that something be to make that work out? Yeah. So I put an plus, you put an I in there. That's 78.7 degrees. So against all odds, the number 1 plus 5i can be rewritten as the square root of 26 e to the I 78.7 degrees. Okay, those two mean the same thing. They are equivalent. Sometimes this version is way more useful than that version, and sometimes the reverse is true. We'll pick up here in a moment, so just keep that hanging there. I want to do a couple more practice with imaginary numbers here at the beginning. I'm going to write that up here so I can give myself a little more space down below. Suppose I wish to add two numbers. Number A is 2 plus 3i, and number B is 5 minus I. Suppose I wish to add them. If I add two numbers, it's like adding vectors. I add the real parts, the imaginary parts, and A plus B then would be 7 plus 2i. Suppose I wish to divide two numbers. Suppose I wish to do A divided by B. If I want to do A divided by B, that becomes a little trickier. I'm not quite sure what to do. What it absolutely is not if you want to get a wrong answer as fast as possible, here's a really fast wrong answer. Divide those parts and then divide those parts. That is a very fast to get wrong answer. That is not the way to do it. One way we could do it
Is use the letters equal. So 5 plus I.
okay, one way we could do it is use what's called, we actually call it the conjugate.
Oh.
So I could do 2 plus 3i divided by 5 minus I. And Isaac's suggesting let's multiply top and bottom by 5 plus I. On the bottom, that will then just give us 25 minus 5i plus 5i, which cancel. 25 minus I times I. What is I times I? Negative 1 because I is equal to the square root of negative 1. So the square root of negative 1 times the square root of negative 1 is negative 1. So here I have negative I times I. So negative times negative 1 gives me 1. 25 plus 1 would be 26. And then on the top, I'd have 10 plus 15i plus 2i plus 3i times I. What's 3i times I? 3i squared, which is negative 3, because I squared is negative 1. So we'd have 7 plus 17i over 26.
Wouldn't the bottom then be 24?
No, because negative, that negative times I times I. The I times I gives me -1, but I have another negative sign that makes it positive. And then now I can divide the 26 into both terms. So I'd get 7 over 26 plus 17 over 26 I. Okay? That is what I get when I divide A by B. Let me show you an alternate way to divide A by B that involves what I might call transformation. It's good to use that word now because I understand you're now doing Laplace transformations in your differential equations class. The purpose of teaching the Laplace transformation is twofold. If the only reason to teach the Laplace transformation was to teach the Laplace transformation, I'm not sure we would bother. It is useful. But what we really want to teach with that is to teach transformations. Transformations are really useful, just in general. You don't know what kind you're going to want to have. So let me do a transformation. This is not a Laplace transformation, but just a transformation.